Class example 3.51. Use an algebraic process to solve each of the following equations. So first, we're going to divide both sides by 3 to isolate the power term. So the term with x in the exponent. And then next we're going to convert this to log form. So notice the pattern. We had base 2, so it's going to be log base 2. And then of 100 is equal to the exponent. That's what log solve for, is the exponent. So now our variable is down on base level. It's not in the exponent anymore. So now we can solve just using algebra. So we're going to isolate for x. So we'll move the 4x term to the left side and log base 2 of 100 to the other side. And then finally, we'll just divide both sides by 4. Now, this is the solution. And this is considered an exact solution. So we'll actually just leave our answer just like that. And then we'll use our calculator to approximate solutions. So x is approximately equal to negative 0.41. Now, if you have an older calculator, like a TI-83 maybe, then you're going to have to just put it in a little bit different. You can't put in base 2, so you'll have to put that in as log 100 over log of 2. And then we can verify our equation as well. So notice though that our answer wasn't quite 300. So if we put in negative 0.41 in for x, we're close though, which actually makes sense because we rounded this. This was only an approximate, so I shouldn't expect that to be exactly 300. But the fact that it's very close, that really most likely means that we're right. All right, let's do B. So isolate the power term again. Convert to log form. So again, base 5, so we're going to be using log base 5. And then isolate for x, so just really moving the 2 over to the other side. This is written with the x on the other side, but same thing. And then put into your calculator to find an approximate solution, or the change of base method with an older calculator. So x is approximately equal to 4.69. And again, we're not quite at 152 when we check our answer, but close enough. All right, so now let's verify graphically. So if we want to verify graphically, what we can do is just graph one side of the equation as my y1 and the other side as my y2. So that's what we have going on here, y1 and y2. Now, we can actually leave our Windows settings really where they were. We don't actually have to worry too much about that. So now, next, you'll go to intersection. And the graph won't look quite right because I can't actually see 300, right? Because y2 is just going to be a straight line at 300, but that would be way up here, right? We can't actually see that, but that's okay. When we're finding the intersection, we're assuming there's only going to be one intersection. So our graphing calculator is asking, okay, is the first curve you're talking about the blue one? So then we'll say yes. And then is the red curve the other one you're talking about when y is 300? And even though we can't see it, we can't really see that little cursor on it, we'll say yes, that was the one we were looking for. And it's saying take a guess. So then I'll push yes one more time. And it tells us where the intersection is. So when y is 300, x is equal to negative 0.41 yada yada, which is what we found, right? That's the same solution we found algebraically. So again, although we can't see it, the graphing calculator was able to find that for us. Another method, just so you guys see the relation here, is to first set our equation equal to 0. So if we would move this 300 to the left side, then you'd be left with 3 times 2 to the power of 5 minus 4x minus 300. and then is equal to 0. So if you do that, we can set, y1 equal to that whole expression, and y2 just equal to 0 this time. So it's just a line on the x-axis. That's our red line there. Okay, and then we can find the intersection of that. And this time we actually can see the cursor. It falls within our window settings. And again, another method, we could also really just use the 0 function. So in the last one, we set y2 equal to 0, right? But what that did, that really just made a line across the x-axis. Well, if we're really trying to find where it crosses the x-axis, then another way of doing that is just finding the 0. So in that case, we find that a little different. The calculator is asking us for the left bound. So you'll just click to the left of where you think the x-intercept is, and then the right bound, and then you'll take a guess. So push enter one more time. And then again, we get the same solution. Okay, so let's quickly look at B. So in B, we are going to move the 152 over to the left side. So, and then you'd be left with the right side of the equation equaling 0. So then putting that in our calculator, and then just solving again for the intersection. Now, one more. We just got one more method to solve this to check that you're on the right track. So we can look at this first example again using the solve function in your calculator. So if you find the catalog button on your calculator, it's in the bottom left on your calculator there. And then once you're in that catalog menu, notice that up in the top right part of your calculator, somewhere up there, it'll show that you're actually in alpha mode. So that means you're ready to start typing letters. So start typing in S, just so that it brings you to the S's or somewhere close. Because this catalog is actually quite large, so it might take you some time to scroll through everything. But once you do that, find solve and push enter. And then if you put in your equation, so this part of your equation, written with X and everything there, then what the solve function does is it sets this first parameter equal to 0. So it's assuming that this is equal to 0. And then set the variable as X, right? Because it just wants to know what we're solving for. So it wants to know we're solving for that. And then the last part here is taking a guess. Well, the good news on this one is actually, since there's only one solution, you could pretty much put any number in for that, and it's going to give you the right answer. The reason why there's a guess button is because sometimes when you're solving, there might be two solutions. So if you wanted to solve for, let's say, the positive solution, then if you put some bigger number in there, some positive number, it would be closer to that, so it would pick that as the solution. But maybe if I had like a negative solution and put like negative 100 or something, then it would find the negative solution. So either way, for us, unless we have two solutions, it's not really going to matter too much because there's only one anyway. So a note on solving equations graphically, however, is while we didn't care about the window settings, and we just found the intersection just by pushing enter a few times and finding the intersections there, in order for this to work on your graphing calculator, the solution must be between the x minimum and the x maximum. So our x min and x max were at 10 just by default. So let's say if our answer had been 11, then your calculator would have said no solution, or there would have been an error or something like that. So you might need to expand your window. So here, let's look at this example. If we solve this one graphically, bring the 45 over to the left side, set it equal to 0. And then graph, find the intersection, and then take a guess. Well, yeah, we get an error. It says we can't do that. So the remedy, just make your x and your y bigger. Make it negative 100, and positive 100. You could have made it negative 1,000 and positive 1,000. It wouldn't actually matter. You just need to make sure it's big enough that that your solution is going to fall within that window.